The subject that we will read in this class is digital system design. Today is the first class. So, first I want to give a introduction of the course, mainly what do we mean by digital system, how we can design or what will be the efficient design of a digital system. So, what we have to learn if we want to design a digital system. So, first we see what do we mean by a system. A system can be defined as a set of related components that work as a whole to achieve a goal. Means that what is a related components means, say some part, that system has a different part, but when they actuate as a whole, then it will be actuate as a whole to achieve a goal. So, system contains inputs, behavior and outputs. Again, let us elaborate this thing. Say if we draw a picture, we see that says initially the system we are as if thinking as a black box. Okay. Now, we are feeding some inputs, and this is the behavior, means how this black box works, or what just now we have defined these related components or the part of the systems as a whole, how they works to produce some output. So, these three together, these inputs, behavior and outputs, we are defining as a system. So, what is this behavior? Behavior is a function that translates inputs to outputs. That means, we are giving these inputs and then what will be the outputs. That means, given a problem that if we give this in these as the inputs, then what will be the output, or how it solves the problem, means what will be the output. So, this is in this way we are defining a system. Now, say these components or that related parts or related components of a system, that can be digital, analog or mixed signal. Now, what do we mean by these digital, analog or mixed signal components? First, we see that the digital system is a system in which signals have a finite number of discrete values, whereas this analog system has values from a continuous set. So, first we elaborate these two things, because digital system is the main concern of our class. So, we understand what do we mean by digital system. Say now, if I draw this thing, that means, say this is my some inputs, because already we have defined that inputs, behavior and outputs. So, these are the inputs and these are the outputs. Now, say again inputs can take some discrete values, not all the values here. Okay. Say these are the some values it can take. Now, for these input, say the output can be, say output can be this one. Say for this input, the output it can take, say this is output can be these values. Similarly, for this input, the output can be this one. Again for this input, say it is taking that same output. That means, see here only 1, 2, 3, these 3 finite values it can take. These we are calling the discrete values. So, this is my digital, these we can take that these are my digital system. Whereas that analog, how we have defined? That analog means we told that the signal can take, this is a system where that signal can take the continuous values, that means a finite infinite set. Here it is a finite set, here it is a infinite set. So, just if we draw, this can be a say continuous function. See that first the input can take, again the input can take any values here, see for, and for each value the output, each value of input, the output can also take any value. So, this is some infinite set. Okay. So, now how we define the mixed signal? So, mixed signal actually this is a mixed of both digital and analog parts. Now, one thing normally that see this mixed signal values, though we are telling that it is that components can be digital and analog, but normally the inputs and outputs that are either inputs can be either digital or analog, output also can be digital or analog. That means, again if we draw some pictorially, if I can say, so again these inputs can be, say the inputs that can take some fixed values. Say for here some of the components it can take this type of digital values. Okay. But for some of the components that output can be that continuous values, that output can be that continuous values. Okay. So, if a system consists of the both the digital as well as the analog signals or analog components, that means that here that inputs can take finite or infinite, as well as output can be also infinite or infinite, then we are thinking that we are telling that these are the mixed signal system. Now, why digital system are favorite? Why we will read the digital systems, or the why will we are eager to know that how we can design a digital system, that what is the advantages of digital system. First thing is the digital representation is very well suited for both numerical and non-numerical information processing. Say non-numerical information processing means, again if we tell, say numerical means that 0, 100 or say 120, again some big numbers if we take some 3, 0, 5, 6, 1. So, what we will see in this class, what we will read, that all these numerical values, whether it is a small number or whether it is a very big number, large number, then the very efficiently we can represent that thing, or the digital system concerns that the digital representation of these numerical numbers will be very simple, that will be very simple representation. Now, say non-numerical. Non-numerical means say our language, say our English language. I am telling that this is a class, this is a class. Okay. Now, see this English language, all are these characters, say here T is character, H is character, I is S, and similarly. So, now this character can be easily digitized. That means, even T characters, first we can represent simple representation, again simple representation of these characters are possible. So, that is why this is simple representation is possible. Okay. So, that we are telling that this is one of the biggest advantage. Now, another is easy to design, particularly the automated design and fabrication. So, as digital system already we have seen, just now I mentioned that it is the representation of numerical as well as non-numerical data or the information that we can easily represent, and only for that reason some simple circuits are available for the design. Say if for this information processing, first how we input this thing or the behavior when we are actually that is the main system design part, that how we can represent this behavior, that means how we can process this numerical or non-numerical data to produce my output. And as it is a very easy to design and it is to automate that thing, that means automated design or that automation of the system, that is very advantageous for digital designs. And again fabrication part also, because nowadays all of we know that mainly the digital design means why it is so popular, because for the digital chips it is within very small area, that small chips that we can implement a system. Now, it is very low cost because the representation is simple, because the design is easy to implement and the automation is possible, and that is why it is very low cost. Now, easy to duplicate similar circuits. Normally, these we call that VLSI circuits, because where that it has a very regular type of structure, these digital systems. So, within a small area we can fit a number of, actually this number varies from thousands to millions of small circuits in a very small area. So, this is easy to duplicate semi-class circuits. Another is the high noise immunity. So, what do we mean by high noise immunity? Means that that small variations of the components cannot change the outputs very fast or even in very large scale. So, actually that means it is a noise immune. So, what we are telling that variations, so that variations can be done by using or by applying some noise or by introducing some noise. So, even if it is a small noise is incorporated or somehow it is noise affected, so then also our digital circuits performs correctly. So, this is a very big advantage, that this is a high noise immunity power. Now, easily controllable by computer, this is the main advantage of the digital systems. See, the finite number of values in a digital system can be represented by a vector of signals with just two values, what we call the binary signals. Let us discuss this point, because this is the main backbone of the digital systems. So, already we have defined that digital system, that it is the system where it can take the only some finite values. Now, say these finite values I am taking only two, the two values. Say these values I am telling 0 and 1. These two values, that is why normally we call this is a binary values, binary values. Now, any number, say I am taking one example, say some example, if we take, say some first taking some numerical numbers, say 0 to 10. Now, if I want to represent, because these are my decimal numbers. Normally 0 to 9, these 10 values are used to represent the decimal numbers. So, these 0 to 10 decimal numbers I want the representation of the binary. Now, say if I want that I will use some 4 digits, means that this using only these 2 values are that 4 numbers. Say that means 0 means, say I am telling all 0, 4, these are the, these I am telling that digital bits. So, digits means that 4 digital bits I am using. 1 means this is, say 0001. Now, 2 means, say I am telling 0010. Actually, how we are getting these numbers we will read in the next class. Say 3 means 0011. This is very easy to, in that similar way I can represent 4, which is nothing but 0100, and say my 10 is 101010. Okay. So, see that if by 4 bit I am representing, see here all the values can be only 0 or 1, 4 digits I have taken, but every digit is either 0 or 1. So, very easily I can represent that thing. So, the computer can easily control, because this is a machine, computer is a machine. So, it can recognize only 2 values, say 0 or 1. That means, if you think that computer is nothing but a combination of switches, millions of switch, then every switch can recognize that it has 2 steps, either on, switch on means it is a 1, if it is a switch off then it is a 0. So, that we can logically we can tell that switch off means this is a this is our 0 and switch on means this is 1. So, only by taking a thousands of switches or millions of switches, I can easily define, or I can easily construct or design a digital systems. So, the device which process this signal is very simple, say switch or open or closed. So, this is the biggest or the main advantage of the digital system. Another thing is the adjustable precision. See, I am giving one example again. If I draw, say I am telling that I have some digital clock. Say my clock is giving some hour and minutes, hour and minutes. So, now it is 12 o'clock. So, 12 hours and 00 minutes. Okay. So, I can, as it is a numerical numbers, so 12 also I can take some digital values. See, this is 1100. Again the previous example, if we take, it is represented by a 4 bit, and this 00 again if we take that, this is 4, all 4 numbers are there. Now, say if one person wants the second also, then say then it is another second is also there. So, it is 12 hours and then 00 minutes and say 20 seconds, then it is 20 seconds. Then again what I can do, that see I can do that 12 is again 1100, again this is 0000. Now, here I have to represent this thing by a So, 20 then I have to take another values. That means, by 4 bit numbers I cannot represent 20. So, then what just I am taking, see, as the 20 here for 20 I need 5 digits. So, this should be 1 0 say 1 0 0. So, I am taking 1 0 1 0 0. So, 16 and 420. So, how I can change? See, easily I can change if I put another 0 here, if I put another 0 here, it remains same. That means, this means my 12, this is my minute representation 0 0, this is my second representation say 20 second. See, that means that precision, if I want to, this is nothing but a precision, that it was earlier hour and minute, now I want to change that thing by a second. So, I am introducing another field, and again it is another field, means this is earlier, if it is second, means I want 5 digits. So, only I need another bit, and that is left hand side, that easily it can be included. So, that is why it is a adjustable precision. Now, complex digital ICs are manufactured with the advent of microelectronics technology. Already I mentioned this, that VLSI technology. This is the reason, because now normally we call that this the world, the current world is digital world. So, that means that wherever that all the systems, that everywhere the digital, it is possible to design a digital design, and the main advantage is that I can in thousands of circuits, or thousands of even large systems, that I can put in a very small area, and that we are called that integrated circuit, or that normally we call that IC chip, or even you can tell that VLSI chips. So, we know that that our starting from our digital calculator, our digital watch, the digital computer, or say if we see that number of applications, mainly that number of all the personal digital assistants, say your mobile phone, your pump top, or any type of electronic goods that we are using nowadays, that everywhere, that mainly why that it is a the size is very miniaturized, and that is possible because it is implemented, or it is designed by, or constructed by the digital design. So, that is the that complex, any complex digital circuits that we can implement, or we can design by digital design. Now, not all are the advantages, some of the disadvantages are there. One thing is that lower speed. So, if we use that analog, though analog has many other disadvantages, but we will not discuss that thing because our main concern is digital system. Then one advantage is that it is very fast, whereas the digital is that speed is lower. And another we should tell, this is not a disadvantage, but we have to it is a costly venture, or some complexities are involved, because that our physical world is analog, means say this I am talking, this is an analog signal. So, or someone is singing, that is an analog thing, mainly the signal we are producing, that is the analog signal. So, if one system is analog, then directly it can catch our analog signal, and it can process whatever it wants. Say I am taking one example again. Say I am taking one analog signal. Say this is one source, I am telling this is one analog source. Okay. This is one analog source, means that it is generating some analog signal values, that can be a song, that can be a some words. Now, directly I want to amplify one simple system I am thinking, that this is I want to amplify. Okay. This is my amplifier. Okay. So, these are the input, I can directly feed these inputs, I can directly put that thing in my, say, my telephone line. This is my, say this is my telephone line, this is my telephone line. So, it is going through the telephone lines, and by telephone again it is some sender, again some, this is a analog receiver, this is an analog receiver, say that it is going. Now, see here there is no conversion is needed, the analog signal is generating, this is being processed, say amplifier is one example, then it is via telephone line it is communicated. Again if it is a telephone line, that means it takes the analog signal, it carries the analog signal, and then some analog receiver is getting that thing. Okay. Now, say I want this if this is digital, I want to incorporate the digital, that means so far it is a digital design. So, needs to digital design means, say our world is analog, means I am talking or someone is singing, that is the analog signal. So, what we want, what we need, I need to convert that analog data to the digital one, because my processing, information processing should be done in digital way, because we are discussing about the digital system design. So, now okay, first to complete this thing, that to analog and vice versa, that means one analog to digital and digital to analog to communicate with real world. Now, this makes the digital system expensive and less precision. So, what we need, again if we draw that thing, say again one analog sender or analog source, what we call the analog source, means some, say some song is produced, some music, this is analog signal. Now, instead of this amplifier, say I have some digital thing, I have some digital systems, Now, see I cannot feed this analog source directly, what I want, then I can't, because this is an analog signal and this is a digital system, means my input should be digital input, output should be digital output. This processing or this behavior, implementation of this behavior, that how it translates or how it converts the input to output, that is also digitally processed. So, I have to, I want one converter here. Okay. So, if I want to change this thing, I want one, say okay, I delete that whole thing and I do that, this is my that one analog source. Okay. Now, I want one converter. This is called analog to digital converter. We normally call A to D converter. And then, so here it is an analog signal, here output is digital. So, now I can easily attach one digital system. Okay. Say some digital amplifier I am telling, earlier it was analog amplifier, so some digital thing, some digital processing, I am telling some digital processing, better I call some digital processing. So, this is some digital processing. So, again this output it is digital. Now, think that see actually it was a song. So, when I want to listen, this should be analog. Say now by I fed it into a computer. So, digital processing, then it is a digital computer. Okay. Now, either within this computer or outside, I need a digital to analog converter. So far all these things are, this is processed the digital. So, I need one digital to analog converter, so that I can, the receiver can listen, that receiver can hear the song. So, this is again a analog receiver. So, see I need this to this conversion and this is the conversion. So, this is somewhere, that is why it is called that this is expensive. So, to communicate with the real world, the digital system is expensive and this is and less precision. Okay. Now, another thing is very important. We are telling our world, our physical world is analog. That means, what we are generating, what we are listening, what we are generating, all are analog. And then it is processed, or that normally it is called say some information processing or data processing, that we are doing by digital, because so far what I mentioned that digital is very that implementation very easy, data representation, whether it is numerical, whether it is non numerical, that is very simple. So, actually some digital abstraction is there, because the real world is analog. So, digital circuits actually deal with analog signals. Say here signal means currents or voltages. See, I have one voltage source that is generating say 10 volt, this is a 10 volt supply. So, it can generate 0 to 10 volts. Say if I can vary that thing. So, 0, 0.5, 1, 1.2, 1.3. So, it can take any values, actually it depends on that the accuracy of the supplier. Now, how I can tell that when it is attached, because one power supply will be needed. So, when it is attached with a digital system, how can we tell that either it is a 1 or it is a 0? So, these we are calling the one abstraction. So, digital abstraction allows analog signals to be ignored and allow some discrete values to be used. What does it mean? See, say I have some analog, again if we take the same example of that power supply, that say one, the analog values can be 0 if it is a say 10 volt power supply, this is 10 volt power supply. Okay. 10 volt power supply. So, it can take 0, 0.5 volts, then 1.2 volts it can be, then it can be 1.8 volts, 9 volts, 2.0 volts, like that, like it can be 5.5, say it can be 5.0, 5.5, 5.8, like 6.0, in that way it will be say 9.8, then 10 volts. See, so many values it can take. See, now you can tell this again, these are some finite values. Okay. Then I need some discrete values to represent. If I want to convert or to represent, rather not convert, if I want to represent this whole set of values digitally, then what I want, say for 0 I want, because these are all separate values. So, for 0 I want one discrete value, say 0. Say for 0 point, say if the precision is 0.5, say I am taking 0.5, then I want, say for this is 1, then say for 1.2 I want another value 2, 1.8 I want another value 3, 1.9 I want another value 4. So, so many values will be there, but just now we mentioned that everything we can represent by binary, by only taking two digital values 0 and 1, 0 and 1. So, we are what we are telling, all these analog values that we are actually we are ignoring. What we are doing, say actually a range of values, logically we represent that thing by a 0, and another range of values we are representing by 1. See, this is 0 to 10 volts. Say I am thinking that if it is or just we are maintaining this, that if it is 0 to say 4.8 volt, then we are telling this would be a 0, this will be treated as a 0. If it is greater than 4.8 volt, it is greater than 4.8 volt, that means 4.8 to 10 volts, then it will be 1. So, now see, actually all this is a range, one range is replaced by one value, another range is replaced by another value 1. So, this we are calling that one digital abstraction. So, example just now what I mentioned, this is a binary system, only two values are allowed, 1 and 0. 1 means high value, say our high value means this high value is a range. So, if it is 5 volt to 10 volt, I am telling this is a high value, or logic true, sometimes this is called a true, means this is on or switch on. 0 means low value, that means if it is 0 to 4.8 volt, if we take that same example, and this is we call that logic false. Now, another two terms are very important when we read that digital systems. One is called synchronous, another is called asynchronous. So, what do you mean by synchronous system? A synchronous system is the elements, if the elements change their values at certain specified times. Certain specified times means some specific times only they can change, and it is normally we call that clocked. We will discuss that thing later. Now, only we can think that the input we can apply the output that the system produce, or even the processing or what we have represented by our behavior when it is processed, that everything is being done at some specific time instant, then we are calling that this is a synchronous system. And asynchronous means that outputs can change at any instant of time. So, there is no fixed or instants that the inputs can change, inputs can apply, outputs can produced at any instant of time, that can be done. One simple example we can see, that again we take the same example of digital clock. It is set to alarm at every minutes. Every minute it will make a sound. So, synchronous means 10:30 it will make, then it is 10:31, 10:32, at every minute it will it will make a sound. Asynchronous means no, it is not in every minute, say 10:30, then 10:42, say 12, difference is 12. Now, it is again 10:50, means 8, that means there is no fixed instant. There the fixed instant was, that period was at 1 minute when we consider the synchronous. If it is asynchronous, again that it can be 12, it can be then 8, again it can be 1. So, there is no fixed instant of time that it can change. The most common example, or actually if we already I have given, I mentioned many examples, digital system examples, or digital calculator is one example. So, if we think that our examples are digital system examples, I can tell that our digital, just a minute, our digital calculator is one example. Another is our digital watch. These are very simple examples. Now, this class mainly will consider the our digital computer as the digital system. If we learn the all the parts, the way we have defined the digital system is one system is a related components, and if here the components are digital block, then we are telling that this is a digital system. So, computer, our digital computer is the example. If we see the design of a computer, then actually the all the concerns of the digital systems, how we can design an efficient or easily understandable digital systems, then that computer is the ideal example. See, in very abstract way, very simple model, I can tell that computer has the very basic, that it has memory and it has some central processing unit, the CPU. See, as a memory, from memory, that instructions and data are going, these are digital data. Again, instructions that we can represent by digitally, because I gave that example, that if it is the English language or English type language, mainly consists of characters only or some other characters, always we can represent that thing by a 0 1 bits. Then again these addresses, these are nothing but digital addresses, means these are 0 1, and this CPU again that inputs which are the nothing but the digital inputs, means again that 0 1 that are fed to the central processing unit, and the outputs are also digital. Now, here some arithmetic logic unit means I want that the thing should be processed. This is CPU. Say that input I fed to the CPU. Then I want that this thing, 2 inputs should be multiplied or the 3 inputs should be added. That means I need some arithmetic to be done. So, this arithmetic logic or again some temporary storage, that also that can be the other parts. Actually, there can be many other attachments. I have given only a simple example. Now, see again this CPU, I can think that this is a digital subsystem. Again my memory system, again this is a digital subsystem, and the two things together, and not only the two, actually that ALU, that other temporary storage, that was all the things together, I can tell that this is a full digital system. So, in this class we will read that first how I can represent these numerical data or non-numerical data, means instructions, is how we can represent that thing digitally. Then how we can process this thing digitally, that means how my arithmetics, my multiplication, addition, subtraction, division, exponentiation, what I know, that how we can digitally we can compute that thing, how digitally we can perform all these arithmetics. Similarly, input I can generate the digital outputs, how we can store that memory in the memory, or it is a permanent storage or whether it is a temporary storage, and all the things we are doing digitally, means only two values we are using, say 0 and 1. Another big thing is the clock, because already I mentioned the synchronous and asynchronous, that means that at only some specific instant of time all these things can be done. So, this clock is also concerned, that means our synchronous system or asynchronous system, that also come into picture. So, we will mainly this course concentrates on the design of a digital computer, and if we learn a digital computer, then this is a digital system design, the full course will be covered. So, mainly this we have to learn. Now, okay. Some more things are, some related things are there when we discuss about the digital systems or digital system design. One is called the specification and implementation of digital designs. See, when a system I want to develop, I want to design, that what do we mean by specification of the system is the description, that what I want by designing this system, what problem actually I want to solve, what will be the function of this system. So, what we can tell simply, specification means the description of its function and other characteristics required for its use, say speed, cost, power. Say what should be the speed of one system, say one system is so slow that the speed is very less. So, actually it is of no use. So, I have to tell that this should be the speed. So, this is some specification of the system. Say cost, say it is very costly. So, people cannot afford, then even I can design a very good system, but the cost is huge, it is very expensive, then it is of no use. Similarly, power. So, that is again main concern. Say in nowadays, that one very good example is our mobile, our cell phone. All of we know that it is nowadays everyone is using that cell phone, but the main drawback till today, the drawback is the power, because we have to charge the every day we have to charge our systems. So, this speed, cost and power, these are the main we can tell these are the specification. So, this performance, cost, power and everyone is related to all the to others characteristics. So, these three are the mainly the main three main three characteristics that are concerned to digital systems. So, design can be improved at the expenses of worsening on or both of the others. That means, say speed can be I can make my system very fast, but the cost increases, as well as that it takes huge power. So, that is worsening the here worsening the cost and power, I can improve my speed, or the vice versa I can do always. So, these trade-offs exist at every level in the system design and every sub piece and component. So, this is one very important thing when we design a digital systems, that what is our specification, that means what is our requirement, that which characteristics means that power, cost or speed, which one I want to emphasize, what is user's choice. Based on that, the system the design can vary, the design of the digital system can vary. So, a designer must make the trade-offs necessary to achieve the function within the constraints, that everything should be the trade-offs can be there. Specification should have following properties. Now, specification means that is the function of the system, how this system behaves. So, this should be simple, but complete, that because our main aim is to automate the design. So, if it is simple, then the representation will also be simple and it should be complete, the specification should be complete, so that your system should be the complete one. The interpretation is unambiguous, that means there must be, when you are giving the specification, this should be a unique specification, because this is a machine, that some circuit which are doing this thing. So, this interpretation should be unambiguous, it cannot have double meanings, okay. Then it will be a problem. Okay. We can another very important thing is implementation. So, in the next class we will discuss that thing. We end here. Thank you. In the last class, the digital system design was introduced. We are discussing about the specification and the implementation of digital systems. Today we will see that what do we mean by implementation of digital system. Implementation means how the system is constructed from smaller and simpler components called modules. The modules can vary from simple gates to complex processes. That means that one system has a related components. We have defined digital system like that. Now, these components, again a set of components or more than one components, that is clustered together, and we are calling that is as a module. And this module can be a set of gates, a combination of simple gates, or it can be a complex processor. Now, digital system follows some hierarchical implementation. So, today we will see that what do we mean by this hierarchy and how that one large digital system can be designed. First, we see that what do we mean by modular design. See, if we see first, we take one page and see that the way we have discussed that as if this is some function or behavior of the system and some inputs are fed and outputs are taken. Now, if this will be a large if this is a large system, what we can do? We can break this thing as a some smaller blocks. Say this behavior as if this is some smaller blocks. Again, it has each of the blocks has its own function. So, this is F1, F2. Function and behavior means that it is normally it is used the same definition. Say F5, X6. Say these are the some blocks. That means these as if this large system is broken into some smaller blocks. There must be some interconnection between these blocks. Okay. So, these each smaller blocks we are calling this is a module. So, mainly this is divide and conquer, means the large system is divided and then the smaller module is designed first. Modules are designed and built separately and then assembled to form the subsystem. Modules are designed and built separately, then assembled to form the subsystems. Why we are doing this thing? Because it simplifies